Welcome to our NMR final project. When first analyzing our NMR, we noticed a small peak at around 7.26. This indicated chloroform D must have been used as our solvent. 3 signals in the NMR represent 3 different types of hydrogens present in the molecule. The shifts of these peaks suggest that there's an ester within the molecule, because esters are usually seen with shifts around 3.7 to 4.4, as well as 2 to 2.2 in an NMR. The peak represented by letter C represents the primary alkane hydrogens with a peak between 1.0 and 1.2. The peak represented by letter B represents the hydrogens in closest proximity to the double bonded O on the ester. The peak represented by letter A represents the hydrogens in closest proximity to the oxygens separating the 2 R chains of the ester. All of this helped lead us to the conclusion of our molecule being ethyl acetate.
After determining that our molecule was ethyl acetate, we began to analyze it in ChemDraw. The A, B, and C peaks represented from the NMR were then labeled in our molecule in ChemDraw. To identify the splitting of each signal, we looked at the neighboring hydrogens to each signal. The signal of 4.4, as seen in our simulated NMR, is labeled on the molecule as A. A has 3 neighboring hydrogens, which is why its signal has 4 peaks, agreeing with the n+1 rule. This is consistent for the B and C signals as well. B has no neighboring hydrogens, and therefore its signal is a singlet. C has 2 neighboring hydrogens, which is why its peak is a triplet. The mass spectrum analysis was able to show the fragments that can be created from our molecule. There are fragments at 87, 70, 59, 45, and 41 that are pictured above mass spectrum. These ones each represent a peak that is seen on the mass spectrum. The fragments of higher masses that are not seen as fragments are most likely due to interference from previous testing done in the machine if it was not cleaned well enough before the next test.